Alright, so this is an Algebra 1 video about solving equations versus simplifying expressions. So I'm going to be jumping in and out of problems and letting you have a few to work on your own. You can turn that into me if I'm your teacher, or turn those into your teacher record, and they can kind of go over your mistakes. But the one thing you want to understand about the difference between equations, which has an equal sign, and expressions, which do not, if it'll let me scoot forward a little bit. Expressions don't have an equal sign. For example, all of these on the page right here are just expressions. You don't know what x is. There's no way to solve for what x is. And so you can only do that. You can only solve for the variable whenever there is an equal sign giving you sides, like left and right side of the equation. So let's start with number 1, and let's check it out. I'm looking for like terms. When I'm looking at this equal sign, I treat it as like left and right side. And 5z is multiplication of some number I don't know, 5 times a number, which we're looking for. And then when you add 4 to it, it's supposed to give you 19. So if we want to, we can take the 4 off of 19 to say, okay, well that 5z would have to equal 15 if you're adding 4 to it to get 19. So now we're thinking, okay, well 5 multiplied against what number is 15? And so this is where you're going to think, we have the opposite of multiplication, you use division to get this number by itself. And there you go. And so things can change with the problem. For example, at number 2, it's not 3 multiplied by y, it's y divided by 3. And that's just one little extra thing that you want to look for, because it'll be treated differently. So we look at number 2, like terms again. I see 10, I see 6, but they're on opposite sides. And so this y over 3 part, that's adding with 6 to become 10, so that better be 4. If you think about it, 4 plus 6 is 10. And so we can take that 6 off of this side, removing 6 from this side, giving you that 4 that we were talking about. And then it's y divided by 3. So this can help us think, okay, that number we're looking for, it's dividing by 3 to give you 4. And so the opposite of division would be multiplication. So we're undoing the equation using opposite operations because there's an equals in the middle, and that gives us 12. So you can even plug it in and see it work. 12 divided by 3 is 4. 4 plus 6 is 10. So I want you to try number 3 on your own. Watch out for what are like terms, because things can switch positions on you. 5z plus 4, y over 3 plus 6, 7, no variable, minus 3x. So still think about what numbers should go together. The numbers without variables should go together, and make sure you really cancel to make 0 when you move something, or 1 if you're multiplying or dividing. So the next section we're going to talk about is expressions. So there's no equal sign. You're just looking to put things together that are the same because they have the same variable with the same exponent. And so in number 1, I don't have any sides. I can't draw my little squiggly barrier. But I see 3a plus 5a, which is 8a. The letter has to follow it. The variable has to go with the result of the coefficients. The coefficients are those numbers in front of the variable. So then we have 7b minus 4b, 3. And now you can't do anything with this. That's your final answer. You're just simplifying it. You're making it smaller. It calculates the same way, but it's less steps. So number 2, you really need to know how to do distribution. This is a big part of Algebra 1, future math classes. And this is 9 times 2x, 18x. 9 times negative 8, negative 72. Most common mistake is students don't multiply the second time. They multiply the first time, but they don't multiply all the way through the parenthesis. So I'm looking at number 3, and you can try 4, 5, and 6 on your own. This 15 is kind of waiting for the distribution, and there may be like terms that come out of it. We'll just have to see. But this is negative 4 times 6, negative 24n. Negative 4 times 3, negative 12. Now, similar to this first problem, like terms do not have to necessarily be next to each other to put them together. For example, I see 15 and I see 12. Now, there's no equals, so there's no reason to change the sign of the operation that's currently there. We just need to put them together. So this is 15 minus 12. That's 3. And then you can either put the negative 24 in here, or you can put it in the front. If you put it in the front, make sure you put a plus in front of 3 because it represents a positive. So you try the next 3 independently and just show them to your teacher, and we'll see how well you're doing. So this exercise slowly gets longer because we're trying to help you master the idea of solving equations, giving you a lot of practice, not just keeping them 1 or 2 steps, but really kind of making you think critically about how to move stuff around to get the variable by itself. So slightly longer, but it kind of combines the idea of what we were talking about just a second ago. In number 1, there's an equal sign, so there are left and right sides, and if I'm changing sides on something, I need to consider these opposite operations. Here it talks about reverse operations in order to cancel stuff to move it to the opposite side. So when I look at number 1, I see 7x and I see a minus 3x. So those are like terms. They're on the same side. I really need to treat them just like an expression in a way, because in their own side, there is simplification that can occur. So 7x minus 3x, 4x. It's still on the left. Everything that went together still is on the left. And now the like terms are on opposite sides. I see 5, I see 17. Those need to go together. But because they're on opposite sides, I have to use opposite operations. So if something plus 5 is 17, if we didn't have the 5 there, that meant the first number, that 4x value, would have to be 12. Its overall value would have to be 12 so that it adds with 5 to become 17. And so that's kind of the logic here. Now this is multiplication. 4 times a number is 12. So we can use division to see how many times 4 goes into 12, and that tells us the 3 we're looking for. So if you were to plug in 3 up here in your calculator in your brain, 7 times 3 plus 5 minus 3 times 3. So instead of x, I'm replacing the idea of what we just determined x to be. And if it gives you 17, then we know we're correct. So 7 times 3, this first position right here, that's 21. If you add 5 to that, that would give you 26. Now you're subtracting whatever 3 times 3 is. And 3 times 3, well, that would give you 9. And 26 minus 9 is exactly 17, which is the reason why x is 3 is correct. So let's try another one that has to do with distribution as the first step. So for example, I've got 9 multiplied against x, 9x. 9 multiplied against 4, 36, and that equals 63. So now it's kind of in a 2-step situation where I've got to put like terms together that are on opposite sides of your equal sign, but I have to consider opposite operations to move it. So let's subtract. Let's see, 9x equals 27. But we don't want to circle that quite yet. I don't know why I'm circling that, because we need to divide by 9 to get 3. You're not really done until you know the exact value of x, not 9x's value, but x's value. So plug that in up here, 3 plus 4, that's 7, and 7 times 9 is 63, so that is working out perfectly. Alright, so give number 3 a shot, and if at any time you need to rewind the video to watch anything, you should. I want you to try 4 on your own, even 5 on your own. Let's talk about number 6. Number 6, this whole side has a division of 4 on the right, which is really kind of holding back the top part from being able to solve. So the way that I think about it is I kind of take my hand and I cover the top part. And so I think to myself, well, what value in the top would divide by 4 to be 8? And I'm thinking about 32, because 32 divided by 4 would be 8. So that's why the first step here should be to multiply the 4 to the other side, so that you can see that the top part better be 32 if this is all going to work out mathematically. So now, go ahead and finish that one. Put your like terms together using your opposite operations, and we'll check your work. Let's go try one that's a little more difficult, maybe number 9. You try 7 and 8. So let's multiply, starting with distribution. That gives you 12y. These multiply to give you negative 20. You subtract 7y and you get negative 60. So if I'm looking at this, I'm still got sides. Even though I started on the left side trying to distribute a little bit, I need to look for like terms possibly that are on the same side. So for example, I'm seeing this 12y minus 7y. Again, it's like simplifying the side before we move stuff to the other side, combine like terms. So that would be 5. Notice that I'm not changing the operation. I'm not adding 7 over. I see that with students that struggle with solving sometimes. They don't really know when to use opposite operations. It's when it's going to the opposite side. Like right here, 20 and 60. Those are like terms. They do not have a variable. So I can undo the process a little bit by adding 20 to negative 60 to see what we get. We get 5y equals negative 60 plus 20, negative 40. If you have negative 60 and you add 20 to it, you're not going to be at 0, but it is going to get you closer to 0, still negative though. Let's divide by 5, and there's your negative 8. So if you were to plug in negative 8 up here, you would see that it all calculates to be exactly negative 60. So use that example to do number 7 if you need to. Number 8 is very similar to what we just did in number 6. So study examples that we've already kind of talked about that look similar and see if you can backtrack through the process. Let's go back to simplifying for a second because I want to see that you understand that it's back and forth. Sometimes you're simplifying, sometimes you're solving. Those are the two main words in most algebra classes that are in the directions. You're either simplifying or you're solving about 80% of the time. Now you're using different skills to do that throughout the chapters, but those are two very common concepts that are used. So no equal sign. I can't draw a squiggly, can't separate the sides because there's really only one side. And I see two like terms right here. 9 minus 4, 5, plus 3. Now I cannot put these together. These are not like terms, which I'm sure you've kind of noticed at this point that we're not putting those things together. We're avoiding that in a lot of situations. But we are kind of combining those things to be a more simplified answer. Negative 5 minus 8. Those are both negative, so it's like you're subtracting deeper and deeper into the number line, giving you negative 13. It's like they add, but stay negative in that negative realm. Let's add 3y to that, and this is done. Can't combine anything there. Number 3, I see a lot of different stuff there, but unfortunately there's not a lot that can go together. I mean, I see 12 plus 5. 12 plus 5 would be 17. But then the negative 13a or minus 13a, however you think of it, that's not any like term that can change, and 7b is no different. And so that one's done. So I'm watching my time here. I never want to go over 15 minutes. And so I want you to try some of these on your own. Ask questions to your teacher whenever you see him next time. And please try all of the problems, okay? We really want to help you out as much as possible, but we definitely want you to get that practice in, and I promise you'll improve. One more, maybe number 7. Looking at like terms here, I don't want to multiply by 2 first. The reason is because if you're going to multiply a side by something, everything has to multiply. So technically you could do that, but you'd have to multiply 9 as well. However, I think it's a little simpler if you just kind of cover up what's kind of complicated here. If I cover up in my mind like this part here, and I'm like, well, 9 plus what is 23? Well, if you're adding 9 to something and getting 23, we could just subtract 9 to the other side so that we can see what this value should equal. I think x over 2 should equal 14, because 9 plus 14 is 23. So now if I'm trying to see, well, what number divides by 2 to give you 14? That meant you had a bigger number than 14. You cut it in half to get 14. So we need to go up, and the opposite of division is multiplication. Let's multiply 2 to the other side and get 28. So now I want you to go ahead and try the rest of it and turn that in to your teacher or turn it into me, and we'll check your work. Good luck, and watch the video again if you need to, and have a good one.